All right. So watch. I'm going to make a mistake. All right, what mistake did I make?
To divide. You need parentheses.
I need parentheses.
Oh.
This, we know what this means. In fact, this is the problem you guys have. When it's written like this, some of you guys rewrite it like this, and you've made an entirely different problem. This means that this is grouped together as the top. This is grouped together as the bottom. We just don't write the parentheses. We're like, it's a big-ass division bar. We don't need them. But then we forget they're there. So that's not going to give me the right answer. Damn! So I can go back. Yeehaw! Oh, this is going to take a while. This probably would be quicker just to retype it. But just to show you, if I do second delete, it'll insert. I can insert parenthesis. I love when I'm about to say, just like on a typewriter, insert. Just like on a computer. And then on the bottom, you want to insert parentheses around it. All right, so now I got the top in parentheses, the bottom in parentheses. It should be able to do this. I have no idea what the answer is. That's fine. So I get that. How are we doing so far? So
I didn't get that. How do you do that again?
We'll just try to type that. To get insert, you have to hit second, the shift key. So you see how insert is above the delete key? Do you guys see that? Anything above another key in blue, you have to hit the second button. It's like a shift button. Now watch. Real quick. If I realize... Nope, that never happens, Java. If I realize that the 5.8 was supposed to be an 8.5. Now this isn't really all that much, but just to show you, if I hit second enter, or if you have the newer calculator, if you just hit the up button and hit enter when you get there. If I hit second enter, it redoes this. So then I can just go up, over, make this an 8.5. It's really nice when you're working with some big-ass thing. You're like, that was supposed to be a 2, and I put a 3, shit. You can just second enter, go back, edit it, so you don't have to put the whole damn thing in again. You guys still with me? Okay.
I can't figure out how to do that.
Do what?
Second insert. It's not working anymore.
Okay. All right.
So second.
No. So if you hit enter, you get the second enter copy. So now you can go around and edit it.
Oh.
If you want to insert something, you go in there. Yeah. And then you can insert something in front of the 9.
Oh, okay, cool.
Don't mix those two together.
Calculators are big as a complicated. I put the 8 for 5 and had a 5, then moved 5, knowing it for this one.
Now the division symbol's gone, right? So do second, insert, division. There you go. Now you get it.
Oh, you do it again.
Well, I think you overwrote it.
Okay.
Yeah. Oh, technology day is always so exciting. Okay.
These calculators are too smart.
I agree, so much. Just to let you know, there are calculators that will factor shit for you, like x squared minus 4x. It'll factor it for you. What is that calculator and how much is it? So you are certainly, it's sure as all hell you're not allowed to use those calculators. As it states on my syllabus, right? Obviously. Because again, calculator passes the course, it goes on to get a great degree and have a great life, meets another calculator, has some babies, and you're stuck in college. Yeah. Okay, now, let's do the thing that this is named for. Let's do some graphing.
Yes.
What button do you think I hit if I wanted to graph y equals something.
Y
Oh
equals.
shit! Oh,
Wait,
all right.
can I ask you a question?
Yes.
How do you do fractions on here?
The division bar is fractions. Now I'll show you something that you wish you knew if you took 88 here. So if you want to do 4 divided by 7, you just 4 over 7, you just do 4 divided by 7, right? You don't need a fraction button for that.
So should I have to find this here or not?
Only if you have other stuff going on around it too. So if you had to do 2/3 divided by 5/8, you can just do this. Yeah, 2/3, 2 over 3 divided by 5 over 8. Now I'm going to show you something that'll blow your mind. Now you put that down on a test or something, your
No, I
teacher
use
will
a
free.
calculator.
Exactly. This is why sometimes I make a part 1 and a part 2 of a test. I'll show you the button to make that turn into a fraction. What should be the most intriguing button on here?
Second.
No.
For what?
Oh.
Graph.
Math. You see the math button?
Where?
Oh.
Oh, I see it. Yeah, I see it.
Hit it.
Hit it.
Hit it.
She said no.
Oh, that's
Thinking-
cool.
I don't know what you guys think when you hear
have
hit
the
it. I think
number, you
Beastie
press
Boys.
This.
What's that?
Fractions. So like you have that 1 point whatever. You enter that fraction.
Now watch. See that very first one?
Chill.
Hit it.
That's the trick.
Enter. Enter.
It actually does that now. You've been doing that for a long time now.
Oh, that's cool.
And of course, if you do 2/3 divided by 5/8, if you do it by hand, don't you do times 8/5,
Yeah.
which is 16/15? And it gives it to you in those terms if it had to be reduced. All right, so don't get overly excited about that because you still have to show me work, but it's nice to be able to check your work, right?
Yeah, I forgot that now.
Okay, so let's focus. Let's go back to graphic. Let's say we want to graph something simple. Y equals x plus 3. So go to y equals. Let me clear this shit. If you got stuff in there, go to it and hit the clear button. Make sure you get rid of all this other stuff. Look how many functions you can plot in here. My God, 10 of them. I love
Are you going to
Y0.
show us how to plot greater than or equal to when it's
Nope.
on the calculator?
Haha. Because to do that, to be honest, you have to download a special program to make the calculator do shading stuff. Or at least to make it shade nicely.
Even on the new ones?
Huh?
Even on the new ones?
I don't know about the new ones, to be honest. I haven't really played around with them in that respect. Because I never
You do
let
it all in your
students
head.
I never let students do it in the calculator. You have to do it by hand. Period. So let's do, what did I say? Doesn't matter what I said. Let's do x minus 5. I don't know what I said, but we'll do x minus 5. Yes?
What button did you press to get the Y1, Y2?
Oh, y equals. Notice everything up on this row, everything up here, has to do with graphing, right? There's a graph button, that's a giveaway. There's a table button, XY table. There's a trace. The calc one is very interesting. We'll talk about that in a minute. There's a zoom, which makes sense. Zoom in, zoom out, right? Format is just the way it's going to look. Window is like, with the normal window is going to be -10 to 10, -10 to 10 on the axes. You can change that window directly instead of zooming. Table set just sets up what the table is going to look, blah, blah, blah. Stat plot is only statistical stuff. We're not going to use that. All right, so please, dear God, we're about to graph something. If you get an error, just let me know. If my stat students were using these calculators last, you're going to be set up for all kinds of stat weirdness. You're going to get an error. All right, let's all hit graph and see what happens.
Hey, graph.
Look at my graph looks terrible.
Oh, this actually looks pretty nice.
Some of you guys are going to have a nice one. You're going to be already set in a standard window. I am not in the standard window. How about anybody else playing along? You guys are okay?
Yeah, mine looks good.
All right, you ready? I'm going to make mine look the same as yours. And if you have one that looks kind of gross like mine does, you want to do the same thing. Hit zoom. Now look at all the options in zoom. Holy shit, zoom box, which means you can draw a box and zoom in on that spot. Zoom in, zoom out, Zoom decimal, which is a really strange one. I want zoom standard, number 6. If everybody does zoom 6, we're all going to have one that looks exactly like this. Standard window is negative 10 to 10 on the x-axis, negative 10 to 10 on the y-axis. That's the standard window. Now, of course, that makes total sense. We already knew the y-intercept was going to be negative 5. We already knew the slope was going to be positive, up 1 over 1. Kabam. So nothing amazing there. Now, what if I want to solve... Is everybody with me? Everybody with me?
Yep.
Okay.
Now, man.
I'm working my way up to that bonus question.
Okay.
Because I know you're sitting back there like, you didn't answer my question yet. What if I want to solve this system of equations graphically? Because I don't want to do it abstract.
Okay, gotcha.
There's a couple. Well, do one thing for me. Do one thing for me. Just to make this a little bit easier to look at. Make that a negative. Negative 2. Right there. You guys with me?
Okay.
All right. So we've already got one of them plotted. Let's go in and plot the other one. So I got y equals x minus 5 in there already. I'm going to make another one y equals negative 2x. Oh, real quick thing about the negatives.
Yes.
Does anyone see that there seems to be 2 negative buttons? One of them is a true negative, the one that my cursor's on, the one that my little mouse tail is on. And the other one, that's a negative. That means negative.
And then minus?
This means strictly minus.
Where's the negative?
Way at the bottom. That's the one I want right now. I want negative 2x, right? I don't want to subtract it from something. So it's just the way it's hardwired. Makes it easier to program this thing. So choose negative 2x. Where's your x button? Oh, shit. I already used the x button, so nobody asked me about it.
Right next to
Got an
alpha?
Yeah, right next to alpha, there's an all-purpose variable button.
Oh, I was just using the.
Oh, I got you. Here, right here is a quick way to access x. All those other variables, don't worry. It's got a t. It's got a weird-ass 0 thing. It's called theta. It's got an n. It's got all kinds, but that's different modes. I'd hope to God somebody would scream out if when we hit y equals, somebody had a bunch of r's and theta things and something. Everybody had a y1, y2, right? Let me know the minute something weird happens. Negative 2x, what was it? Plus...
11.114.
Now, real quick, before I do this, am I going to be able to see that y-intercept when I plot it?
Not necessarily.
Who was paying enough attention? And that one's on standard window, so it goes from negative 10 to 10, and the y-intercept for that second guy is 11.114. The y-intercept's going to be off the screen.
That's okay.
Yeah, that's okay. As long as I can see, where's the answer going to be for this? Where they meet. If I can't see where they meet, that's a problem. Then I might want to change my window so I can see where the freak they meet. So let's see if I can see that. Yay! All right, sweet. Yes?
Okay, so real quick, how would you trace to find that actual?
All right, here we go. That's the whole reason I'm doing this.
No.
What do you want to find between those two? You want to find the
Solution.
between those two lines. You want to find out where they meet. Another word for meet is intersect. And I want the calculator to calculate that intersection.
Yes.
You guys with me? So I'm going to go to calc. Remember that top row is all about graphing?
So it's good in count.
Go up to calc. See, I got to hit second trace to get to calc. And look at all the shit I can do.
This would have been helpful.
Yeah. Now, which one do I want at the moment?
Intersect.
Intersect.
What's the difference between value and intercept?
Value lets you plug in an x and it tells you the y.
Oh, okay.
0 tells you where it hits the x-axis. That's another name for x-intercept.
Second.
Min and max is if I have a graph like that or that, I find the min-max, right? The last two up there are calculus, so do not worry about those. So let's do intersect. Let me catch up to you guys. By the way, I can't remember. I don't think I put this. Did I put this up on the website? Did I put the TI guide up on the website yet? Yes, I did. Good. All right, thank God. So if you want to have a guide telling you how to do various things, it's there. If you don't want that, you don't have to go get it. So if I hit 5, it's going to ask me 3 questions. Right?
What's the first curve?
All right, so I could have like 7 curves up here, meaning 7 functions graphed. And I want to find the intersection of the 6th one and the 7th one. So I've got to move my cursor to the curves I want. Now, how many curves do we have? How many functions do we have up there right now? Just 2. In fact, you're probably only going to ever have 2 at most at once. So do you see how I'm sitting on one of the curves right now?
Yes.
Okay. So if I hit enter, it's going to bounce to the next curve. And then I got to hit enter because that's going to be the second curve. So the 3 questions it's going to ask me is what's your quest? No, what's the first curve? What's the second curve? And then give me a guess to the answer. So my first curve, I'm sitting on one of them. Let me hit enter. Now see how it bounced up here?
We're looking for the actual intersect.
Yes, but you could have multiple functions graphed. It can only find the intersection between 2 of them at a time. So it's got it preset. It's going to always ask you these 3 questions. What's the first curve you want? What's the second curve you want? And then give me a guess.
How do I know what I want it to be?
You've only got 2 curves. So it's really always going to be what you just hit enter. It bounces to the second curve. You hit enter. It asks you for a guess, so you move it to the guess and you hit enter. So let me do this again.
And then you get some
So
crazy
look, real
numbers.
quick, just remind you guys, can't I have like 10 functions in there?
Yes.
And if I want an intersection, I can only ask it for the intersection between 2 of them at a time. So that's why it asked me, what's the first thing you want, and what's the second thing you want, and then give me a guess for the answer so I can do my algorithm and figure out what it is.
Oh, so you can graph multiple, but it'll...
Yeah, look at all these. How many did we do?
But
2.
you can find the intersect while...
Of 2 of them.
Yeah, but you can have multiple graphs.
On the screen.
Yeah,
Beautiful.
okay.
That's why it wants me to pick out the 2 that I
Gotcha.
want. Now, we only have 2 in there.
Yeah, I hear you. Now
Right.
now I get what you're saying.
Okay, good, good, good.
Curve is line.
So if I go back to calc, intersect, first curve, and get over the fact that it's saying the word curve.
That's what I'm saying. Is that a line?
This is a straight curve. You gotta love that shit.
Okay.
The way we reference any graph is we talk about the curve.
Okay.
Even if it's straight, we say it's a straight curve. Just like, have you guys ever heard of a straight angle? 180 degrees is a straight angle, and you're like, sure, why not? So this is even worse. There's a straight curve.
So anywhere on the line is fine.
I want his picture to throw a straight curve on. So yeah, anywhere on that identifies that. So that if I hit enter, it bounces to the next one. That is the curve, the other curve I want, isn't it? Because I only got 2 in there. So hit enter, and then it says, give me a guess. So let me move the cursor over. Bam. Now, if you hit up and down, it's going to bounce between the 2 lines. To move on the line, you have to hit left and right.
So enter, bounce up, then redo.
All right, here we go. I'm going to do it again. And let me tell you the ultimate shortcut for this. If we only ever plot 2 lines at a time, what I tell people is, before you answer any stupid question, just put the dang cursor on the answer. And then go enter, enter, enter. Because it bounces to the second one for you. So you ain't got to do shit. If you put it on the guess, enter, it bounces to the second one, enter, it asks for a guess. You were there from the beginning, enter. Make sure you can get that answer. Can somebody tell me then, from what we see on the screen, what is the answer to this?
That up there?
That up there, that point, 5.37 blah, 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 comma, 0.37 blah, blah, blah.
Oh, yuck.
But thank God, you know.
Yeah.
Oh, shit. Oh, Tara. Oh, is Tara still here? No? Oh, she's around. She'll be back. Okay. She gave me her chase card, but I'm not going to use it. All right. Any questions on that right there?
Yeah,
Yes.
so
1.11. Yep. Oh, you can see it. I don't know how you did it. I think, did you just trace? All right. All right. I'm not sure what you did. Okay. Is that decent for that? Now, on that handout on the website, it tells you all these steps, right? I think the bonus question talked about. Some nice Samaritan gave it to me. What was the bonus question about again? It was, where'd it go? Oh, to solve that, okay. Now watch. So the bonus question of the test was this. Use the calculator to solve. This next thing is going to, if you really think about it, it's going to completely blow your mind. 2x cubed minus 1.3 equals negative 2.6x plus 5. Now, how would you solve this by hand? You would get one side equal to 0, and try to factor it. Can you factor this? No. Can you use quadratic? No, it's a cube. You can't do it by hand. Do you understand? So what we're about to do can be used for any equation that has ever existed and ever will exist. You can solve it with the graphing calculator. Just watch what this says. This says, I want this to equal this. Isn't that exactly what we just did? If I put y1 equals this thing, and y2 equals this thing, I see where they equal each other, where they meet.
Oh.
Let's try it. So put this in for y1, put this in for y2.
I was trying to find the equal sign.
Yeah, me too.
There we go. So 2x cubed. Here's our to the button right there. Look. Right there. It's what I call the to the button. The little caret. To the third. Now be careful. If you have the newer calculator and you do to the, see how it puts an exponent up like it would normally look?
Yeah.
But then you have to hit the over button to come the hell back down, or else everything you write is going to be up in the exponent. That's
How
going
do you go back down? Where's
You
that
just
button?
hit the over button.
Yeah.
No, that didn't work.
What's happening?
Oh, there we go.
Okay. So 2x cubed minus 1.3. That's one equation. Enter. And the other side, negative 2.6x plus 5. Now let's see if we can see what we need to see on the window. How many C's? So here comes 2x cubed minus 1.3, and now here comes negative 2.6x plus 5. Can we see the answer?
Yeah.
I can see it, and now we know how to find it. So go ahead and try to find an answer if you're playing along.
Got something funky.
You put a square in there. Yeah. It's supposed to be cubed. Right, yeah. Oh, your tick marks aren't showing up. That's interesting.
So, really quick, calc.
Trace.
Yeah, second, then trace, and then we'll hit calc. And then you just go all the way to marks that show that. So then it's a second, you press enter.
Oh.
Yeah.
All right, so then I do second calc, intersect, go to the answer, as close as I can get,
Yeah, so it jumps.
enter, enter, enter. And that's what I get.
I didn't get that.
I didn't get that either.
Did you hit enter, enter, enter?
I got it.
But mine doesn't look like yours does.
Oh, shit. You left the X off. See this? Insert X. Yeah. There you go.
What did I do wrong?
That's why.
Let's see. That's U minus 1.3. That's good.
Jeff, how would you write as the answer?
All right, now real quick. Now this one, what's the answer?
The graph.
No.
1.17950.
1
Y doesn't matter or shit. Does that show up in the problem?
No.
No. So the question is, when is this equal to this? When x is 1.175. The y piece tells you what they both are. This equation doesn't give a shit what they are. It just wants to know where are they equal when x is 1.175, blah, blah.
Oh. Nice. I
So
like
even
that.
an equation you can solve by hand, you can check it by plotting them and doing the intersection if you have all that kind of time. Right? So if I give you some ugly thing, you've got to factor it, you can actually check the answer by plotting both sides of the equation they gave you and seeing where they meet. Okay, maybe?
Yeah.
But this is not saying I'm letting it take the place of actual work. You know what work is to me, and work is everything to me. Okay. What's on here? Any quick little questions while I got the calculator up here? Yes.
So would we ever run into one of those questions where like we can't do it and we have to do it on the calculator?
I tell you,
Yeah.
use the graphing calculator, just like I did in that bonus question. Right?
There's
Use
one
the
in
graphing
homework
calculator.
that says you have to have a graphic calculator to graph it.
There you go.
991 or something.
And now we know how to do it.
Yes, now I can do that one.
Sweet. All right, everybody decent then with the calculator for the moment? All right, obviously every now and again we'll do more calculator work as we hit more and more stuff that we got to be able to do. Do you guys want to take a break, or you want to get into something and take a break later? Who wants to take a break right now?
Break.
All right, looks like we're going to take a break later. The rest of you might just be too tired to vote. I don't know, but too damn bad. You better not be that way when it's actually time to frickin' vote. In the Get out there before weird shit happens again.
I blame my congressman. I blame my representative.
That's what they're there for. It's all good. All right. Let's do a little bit. Let's do a little bit. And then we'll take a break. I want to start off nice. Let's start off nice. It always sounds good. What do I mean by that? Let's start off with a system of just two equations, right? Little tiny system just to get used to what a matrix
9.3.
is. Yeah, this is section 9.3. Line 2 is the word problems.
All
Yeah.
word problems.
Yeah,
Lots of fun.
always. Oh, that's right. Forgot I had this. Well, maybe we don't need that. That'll be fine. Okay. So matrices. So let me give you this. I was trying to figure out how much I want to lecture before I give this. I think I'm going to give you this and lecture from this stuff here. I got a little set of notes for you guys. To help you. So, I think I said this yesterday, but just to make this a big point, a matrices, they exist on their own. There's a lot of uses for them, not just the one specific thing we're going to use them for. So the very first thing I say on here is, here's a few examples of some matrices. You can see them down there. Matrices have parts in them. They can be like that. They could be long. So forth. So let's talk about real quick the dimensions of a matrix. Just like the dimensions of a piece of wood, 2x4 or whatever. How many rows are in this matrix? How many rows? 3 rows. Beautiful, because the columns go like this, right? Just like real columns in architecture, they go up and down. So rows, there's 1, 2, 3 rows. 3 rows. Where's my good one? There you are. And then how many columns are there?
2.
2 columns. So we would call this a 3x2 matrix. Just like a 2x4 piece of wood or something, right? You guys get that idea? It's a 3x2 matrix. So this would be a who to what?
2x2.
2x2. This is also called a square matrix, which is nice. So 3x3, 4x4, 5x5, they would all be square matrices. That only makes sense. Same this way as that way. So this would be a 2x2. This would be a,
5x2.
yeah, remember it's rows by columns.
Gotcha.
Rows by columns, so it'd be a 2x5. I like it. You would, Jeff, yes, sir. How are we doing so far? And that's so we're going to use matrices in a very, very, very specific way. But they are things that exist on their own. I can talk about, I'm not going to, but I can talk about adding matrices, multiplying matrices. They have their own algebra stuff going on. It's like numbers to the next level. And you're like, let's not do that. I'm like, okay, it's fine. Now the way we reference, well, how would you identify that position? How would you tell somebody where that number is? It's in the second column and second row. So second row, second column. So I would call this A22. So what about this guy? Let's make sure we understand where those are coming from. He's in the what row? Third row. First column. So the A31 element is the third row, first column number. Just a quick way to reference all the spots, right? Instead of saying, go to the third row, no, A31. Okay, I know what that means now. I can get there, right? Yes?
Do you need like a comma to separate like
No.
Just like that?
Just like that. I like it. Only if they get up to be higher than a single digit, then you start worrying about separating them, yeah. Okay.
What if it's asking for a number that's twice?
Oh, no. I wouldn't, that would be so mean if I said, where's 3 and there's 2 3s, right? I'd say, how do you identify this 3? A circle or something. I mean, in fact, I don't know if I'm going to ask you about this. I just want you to know this is how we reference the elements of this matrix. So the words make it sound worse than it really is. This is not that bad yet. Okay. So let's talk about specifically, there's some real basics of matrices. Just how to give them a name, how to talk about the parts, and what they look like. I mean, that's the real basics. So let's talk about specifically how we're going to use them. Just a little bit, and then we'll take a break. So we got this here. In fact, I kind of prepped you for this yesterday. Remember, I tried to say it's related to the idea behind synthetic division. I want to rewrite it so the variables are not there, because they don't really matter at first. All that really matters is the numbers. They're what tells me how to make them cancel, right? There's a 3x and an x. I got to multiply one of them by -3 because there's a 3 and a 1. The numbers tell me what to do. Okay. So there's the idea of what's called an augmented matrix. This is nothing amazing. Here's what this is. We basically did this yesterday. I just didn't make it very specific. If I have this set of equations here, here's how I make it look like a matrix. This is the matrix form of this system. The matrix form of this system would be focusing on the coefficients. one extra little thing I want to add in from what we did yesterday. So what are the coefficients of the first row, which is the first equation? So every row is an equation. You guys get that? So what would the first row look like, the coefficients? No. 1, 2, and let me do this. 7. That line is like where the equal sign is. So these are the things that have variables, and these are the things that are just pure numbers. We want to separate them, because otherwise they'll get into a fight. What about this one, of course? Become a 3. Okay. That's relatively easy by itself. Of course, that's just the first step of the problem, but you got to understand this step. So, do you guys see? Let me put this up here. Right where it says Augmented Matrix in bold, you see right below that it asks you to do something? Can you do that thing? Right here. Which one were you? You're this other one. I love that. Okay. So you get it or you don't moment. So what would that look like, of course? What goes here? 2. Negative 1. 4. Negative 3. Now be careful here, right? There's 1x. Remember all, so that first row, that first column, sorry, has to be your x column. And I said yesterday it's because I want all the like terms to line up. Because they're going to start adding rows together, and I can't do that unless they're like terms. So what do I have none of? Y's. And what goes in here for the z's?
-4, 5.
5. And then 6, negative 1, 2, 10. So that's what the matrix looks like for that system of equations. Now, before I talk, to be honest, before I talk about this part, I should have switched these. Can you guys do this on the bottom? Let me add in what they forgot. Poor little people. On the bottom there, the two last ones on the bottom, can you convert that back into equations?
Like add them together?
No, just convert, just do what we just did in reverse. Make the equations.
Oh, for the bottom part.
Yeah.
Gotcha.
Yes.
Is that right column the pure numbers?
Yes.
Oh, even though there's just not. Oh, I see what you mean.
Sorry, yeah. Some of my colleagues don't use the line. This is some sheets I stole from a lecture notebook they used in what used to be Math 298, which is like 90 and 110 combined. They just don't agree with some of the correct notation. Yeah, Jeff. So that, what's his first equation going to be?
X minus 4y.
And then the second equation.
Y equals 2.
So that's a pretty good form. It's a decent form. I know what y is. But this is a much better form even, right?
Yeah.
This is the final form. So, what are the equations here?
X equals -4. Y equals 7. Z equals 2.
Will it ever be one to 4 columns?
Oh, hell yeah.
And then the
So what I want you to realize, and this is a beautiful question, everything we're doing, what's going to suck at first, you guys have got to understand this going in. How much have you used matrices before?
Never.
Okay then, a little bit. If you've used a little bit or never, then it's going to be a bit of a learning curve, right? You got to learn how they work, and you're going to go, Jeff, you said this made this shit easier, and so far it's making it all so much harder. And of course it is, because you don't know how the hell matrices work yet. So, to be really honest, to solve a 2x2, a two equations, two unknowns, to solve that with a matrix takes a little longer than it does by hand, to be completely honest with you. So I wouldn't do that normally. I do assign some problems that have you do it, just so it's a little thing that you can use real quick to get used to matrices. Are you with me? 3x3, like and when I say 3x3, I mean 3 equations, 3 unknowns. Right? There would be an answer thing too. That's why I call it augmented matrix. We add that part on, the answers, the numbers. We put a line and we add those on. They're about the same amount of work, to be honest. But then, can you imagine if I had x plus y plus z plus w equals 11, x minus 2y plus 4z minus 6w equals 2, and I have 4 equations with 4 unknowns. Doing that by hand would suck so bad. But the matrix work, if you add one more row, doesn't really increase the amount of work that much at all. Barely. And then if you add another row, barely, but another row, barely. So this algorithm we're going to use, this process of solving it with a matrix, makes anything at all bigger so much quicker. And this is basically the mathematics behind Excel spreadsheets. If you've ever used or seen or heard of Excel spreadsheets, they use matrix algebra all the damn time because it's a big-ass matrix, isn't it?
Yes.
Bunch of rows, bunch of columns. You ask it to do shit, and it does matrix shit to it.
Totally.
I like it. Okay. So watch this. I want you to realize this form kicks ass. Do you see the form 1, 0, 0, 0, 1, 0, 0, 0, 1? Zeros are beautiful. Why are zeros beautiful in a matrix? What's the whole point of solving a system of equations? I'm trying to kill letters. And if I kill a variable, what does that mean the coefficient is? So zeros in a matrix means you've killed that variable, which is good. Right? You can get a little frustration. I hate variables. I get to kill them in Jeff's class. Kick ass. So zeros means you've killed it. That is the best matrix possible because I can just read the stupid answer off. There's the answer. Bam. So this is what's called reduced row echelon form. Get over the freaky ass words. It's called reduced row echelon form. And that form is going to be for a system of 2 equations. It would look like this. 1, 0 number, 0, 1 number. Right? This would mean that x equals that number and y equals that number. It's been solved. That means it's solved. It's done. That's why that's the best form, because then you're done. For a system of 3 equations, it's obviously 1, 0, 0, 0, 1, 0, 0, 0, 1. Oh, and then numbers. Number, number, number. For a system of 4 equations, it would be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Right? Just ones down the diagonal. Is that cool if I say that? Ones down the diagonal. You guys see that?
Yeah.
So the next step of this is how do I take this and make it look like that, because then all the answers are just sitting there staring me in the face. That sounds nice, Jeff. All right, so now I left that teaser out there. Let's take a break. Let's come back 5 till. I'll be back in here 5 till. Cool.
So Jeff, I have a question.
Mm-hmm.
When it comes to like a newer T84 or